All right, here we go with Unit 6, Day 1 notes. So we're talking about polygons, and we're going to talk about polygon shapes. Essentially, those are what they are. A polygon is a 2D, so two-dimensional or flat plane figure formed by 3 or more segments that intersect only at their vertices. So they make the corners of the shape. Each segment that forms a polygon is a side of the polygon. The common point of two sides is a vertex of the polygon. And a segment, I had a rough start before the other one, a segment that connects any two, and they say non-adjacent. So vertices is a diagonal. All right, so doesn't matter how many sides it is. So there, 2, 3, 4, 5, 6. All right, side, vertex. Anything that goes across the shape, this is diagonal. And of course it says you have to have at least 3 sides, so 3 or more segments, because a 3 would be a triangle, and then you would make other shapes as they got bigger. And some of these names, which you're expected to know. So 3 sides, definitely we know it's a triangle. 4 sides is a quadrilateral. 5 sides is a pentagon. 6 sides is a hexagon. So 6 and x and 6, x and hex. The one that's commonly not known is heptagon for 7. 8 is octagon. 9 is nonagon. 12 is, just kidding, 10 is decagon. So know that before we get to 12 which is dodecagon. Dove meaning 2 and 10 for decagon, so 2 plus 10. Now the other ones, more sides, 13, 14, 11, 25, they have names, but you're not expected to know them. So anything else would be as an n-gon. So n is the number of sides in a shape. So anything other than these ones will look like this. For example, a 17 sides shape. So 17 gon means 17 sides. Or if you ended up with a 22 for an answer and I asked what's the name of it, you would write 22 gon. Another vocabulary thing here is the word regular. Regular means there's lots of symmetry to it. Alright, so there's one of my cats. A polygon that is both equilateral and equiangular. Okay, so equilateral means all equal sides. So symmetry is in the shape no matter if you're looking at sides or angles. Equiangular is all congruent angles. So if a polygon, it does not have these properties. So if maybe it has all the sides that are equal, but not all the angles. If it's not regular, it's called irregular. So the word regular with IR in front. All right, on the back, the words concave and convex. Usually I think of the word concave first. So if a polygon is concave, if any vertex of a polygon contains points in the interior of the polygon. So concave, I think of like caving in. So I think of, you have a shape with many sides, like a crown, or if anything goes in, so it goes towards the inside, this is concave. If you ever think of, a star that's drawn in like with not the crisscross patterns, or maybe, yeah, those two. Some of the points go out, some of the points go in. If they go in at all, it's referred to as a concave polygon. And so if you know that one, convex is the reverse. Convex is making sure every single point goes out, nothing goes into the shape. All right, so if no diagonal contains points in the interior. All right, so if no diagonal contains points in the interior, this is awkward wording, but then the polygon is convex. A regular polygon is always convex. So we've seen the triangle when we did that unit. You have all equal sides and all equal angles. All of them are pointing outside. Another one would be a square, where you have a square with all equal sides and all 90-degree angles. But every shape, pentagon, hexagon, heptagon, will have a regular one, but lots of ones that are not regular. All right, so looking at these, determine if it's a polygon. So polygon can have no gaps, no arcs, all flat sides. All right, so when you start seeing something like this in which there's a gap on there, this is not a polygon. Not a polygon. And explain why. Because of a gap. Okay, so when you look at number 2, the same thing. You're looking at, okay, all flat sides. So this is yes. It's a polygon. We got 1, 2, 3, 4, 5, 6, 7 sides. So it's a heptagon. Now, the third one is a little tricky because if I separate it kind of in the middle, I have a triangle on top and a triangle on bottom. But I'm looking at this as one shape. So as one shape, this is not because there's overlap. Anytime there's overlap, it just makes more than one shape, so that is not one single polygon. And number 4 is also a no or not because of the arc, All right, so then regular versus irregular on the next one, and concave versus convex. Now, regular, you want every single angle to have the same mark or the same measure, and every single side to have the same value or same mark. So this is regular. And automatically this is convex. Now, when you look at something like this, it folds in, so this is concave. But right away, you can see on the sides they have different values, and all the angles pointing out are not the same. So this is irregular. For number 7, all the angles are equal, which is great, but all the sides are not the same, so this is still irregular. Everything has to have symmetry to it, and it's convex. Number 8, all sides are the same, which is great, but all angles are not quite the same. We're close. We got 2 are the same and 2 are the same. This is actually a rhombus, which is not regular, but we'll talk about that later in this unit. And this is convex. 10, all angles the same, all sides the same, so this is regular. and convex. And this last one, we got all equal sides and all the angles pointing out. All right. What do I have here? I got, yep, all equal sides, which is great. So this is regular and concave. So the only thing that makes me question here is how those angles are determined. So based on the angles pointing out is what I'm looking at. So the angles pointing out are all the same and all the sides are the same. So let's just say regular and concave, and I would go with that. So that is the first day of homework, which covers that. You have homework based on the same thing, looking at the shapes, determining if concave, convex, and that sort of stuff.